I want to talk about debris flow modeling. On January 9th, 2018, there was a major debris flow event, or a mudslide, that occurred in Montecito, California. Dr. Sylvia Nittel is doing research regarding sensor data streams for real-time emergency response systems. As an input to this system, we are trying to simulate social media streams of people immediately affected by the ongoing Montecito slide. So our goal was to try to reconstruct this event. How do we do it? Our first task was to create a map. We were primarily interested in the Montecito Creek area because it was the largest debris flow. In the fall of 2017, California experienced its largest wildfire, called the Thomas Fire. The map on the right shows only a very small portion of the Thomas Fire, the area in red. The polygon in yellow is the USGS's debris flow estimate area, which is the watershed that feeds into the Montecito Creek. The lighter colored polygon, which follows the Montecito Creek, is the actual mudslide estimated area. We also included roads and streams, and we used a 10-meter digital elevation model for our calculations. The area with the green dots is our calculation domain. We found a piece of software called the Rapid Mass Movement Simulation, or RAMS for short. And we found a particular version of this software called debris flow, which was exactly what we wanted. This software was developed by the WSL Institute for Snow and Avalanche Research in Switzerland. The way you use the software is to first create a project. You select a digital elevation model and you specify a project area rectangle. You then set up a release area, which is the polygon in red, and you set up a calculation domain, which is an area in green. The nice thing about this software is it works with regular GIS shapefiles, so you can either import these files or you can digitize them directly from within the software. The next step is to run a simulation. With the previously defined release area, you specify a release depth. You use the calculation domain that I showed you on the previous map. The next step is to define some simulation parameters such as end time and dump step. Dump step is how often the software writes data to the disk. The most important parameters are the friction parameters mu and xi. These two parameters control the characteristics of the debris itself. Once the simulation completes, it will create another file. Below shows an example of the simulation results max flow height. With the completed simulation, we can create an animated GIF which shows the debris flow itself. Thank you for watching this video.